These are important things.
Yeah, they are.
All right, let's see here. All right, so apparently the problem with my code was not taking into consideration the beginning or ending of the list very well. So for the sake of time, rather than fixing it, I just stole Jason's solution. Yours worked, didn't it? All right. Yeah, he's got a lot of if statements in it. But effectively, he's saying if it's in the middle, do one set of things. Otherwise, if it's on one of the ends, do something a little different. All right, so I'll put that up there so you can kind of go through it. But it's still along the same lines as we did last time. It's just hooking up a couple of things that we forgot to hook up last time. Again, I put that stuff in there on purpose. Obviously, so that you would have something to do for homework and have to work through it. So in any case, but I want to get to creating a deck of cards and funny enough, after we just sorted it, we want to shuffle it to get a. But we're going to use your swap method to do that, so it'll work out great. Okay, so in any case, right now we're only collecting minions, and so we have effectively a deck of minions, even though there are other kinds of cards in there. But we're going to stick with minions just in case we want to do something relative to defense. If we have cards pit against other cards here, just in like a death fight, having them all have attack and defense is probably going to be beneficial for us. So that's kind of the world we're going to work with here. Up on all the screens. Okay. So with that in mind, if I go back out here to driver, we're still calling insertion sort on defense. On my display function right now, I show the very first card and the very last card just to show that it's likely sorted. And that gets you something that looks like this. Here's your bucket 0 with a defense of 0. And here is bucket, that last bucket, but 1900 something or other. And that is Nefarian with a defense of 200. So it appears like this is sorting them reasonably. We do have multiple Nefarians in here. Maybe there's a couple of interesting history thing. So I was a big World of Warcraft player for years and years and years. And I used to, when I was probably most of your age, I kind of played World of Warcraft professionally as a raider. I was in a big group that we did raids, and we were the world's first kill of Nefarian, which is in Blackwing Lair on World of Warcraft. So that was the second year WoW was out, was when we killed Nefarian. We were world first kill. The more you know. All right. Now I play card games. It's a little bit. Well, it's because I can play them competently now. All these other games move too quick. I do like playing first-person shooters with students. But it has much more to do with them laughing at me because I'm so bad at them. I run out of bullets and then they have to come and kill me so I get a new gun. Because I can never pick them up. Everything's moving too fast. I bump into walls. It's a thing. Well, I tried that. I'm terrible at that too. I actually can usually survive a pretty good amount of time in Fortnite by accident. And the reason it's accident is I'm so bad at it that I move so randomly and I don't engage because I can't find people that I'm like one of the last ones they have to finally hunt down. I'm not a threat. And I'm just not, it's the whole strategy. Sometimes I get stuck in buildings. Those stairs, it's the stairs. I get upstairs and I can't get back down. It's terrible. He knows exactly what I'm saying. You play the game, don't you? And you see people like me and they're like, noob. We'll get back to him later. Guy doesn't have a weapon. I just put myself in a little cage. I'm just waiting. But students tend to have fun playing some of those games against me and just kicking my butt. All right, so we have now a link list of our all of our minions, and we have proven that we're able to sort these using Jason's upgraded swap function, which is better than my swap function. But now we're going to use that swap function to, we're going to call it shuffle our deck, okay? Because we're going to have a deck of these cards, and a deck is going to be based around a linked list. Really, it's going to be based around a stack, right? So we're going to add a couple of things to our linked list here. So let's go in here and create some of that stuff. So we're going to go ahead and we're going to create a deck. So we're going to say class deck. But we're actually going to say that a deck is a linked list. Is it just one of those? There we go. So this is the inheritance model in C++. So instead of deck coming from the default object like this, is it lowercase object in C? Whatever it is. We're saying that we're actually going to build a deck in terms of a linked list. All right. So a deck in and of itself is going to be a linked list. So we'll go ahead and have our public and our private sections here. We'll get back to the public section here in a second. Let's just build ourselves a generic deck just to get the inheritance model working correctly, because then we're going to add some stuff. So a deck should be able to do things like shuffle itself, right? Things like that. Probably deal a card off the top. We might want to go and add some abilities to our linked list. Right now our linked list just allows us to put stuff in and get, so actually technically we can get from bucket 0 if we wanted to, but it doesn't actually remove it. So we maybe want to do some stuff like that. Although, with that in mind, we maybe don't want to remove stuff from our deck. We just want to keep track of where the top of our deck is. That way, when we're ready to restart the game, we just go back and create a new, just kind of reset the deck to be the very first card and then reshuffle it or something like that. It doesn't need to be perfect. We'll come up with something. We won't waste a lot of time on it. But we're going to have our public constructor. Actually, I usually do the private section first, right? Doesn't have to be, but that makes sense. So in our constructor here, we're going to go ahead and have our deck. And what I'm going to do is we're going to go into, well, we'll do this when we implement our deck here in a second. So let's just start with this as a baseline. Right now, if we go out and we look at our driver's starting to get pretty messy, right? We got a lot of this stuff in here. So really, this stuff that we're doing right here is probably stuff that can live inside of our deck. When we first instantiate a deck, we can say, go and grab the cards, load them into the linked list aspect of yourself. So that way our driver looks a lot cleaner than this, because we have a lot of stuff here and we want to look at encapsulation and getting some of this detail just behind a closed door inside of our deck object. So we'll go ahead and write our constructor for deck. So we'll create a deck CPP. And this guy will include deck HPP. All right. Now, the very first thing we want to do here is we want to call our parents constructor. Isn't that how we call our parents constructor? We should have access to that. We have access to this. Give me a moment. Let's do it with structs. I want it in a class. Oh, it looks like it gets called automatically if your constructor has the same arguments in it as your parent's constructor does. So in our case here, because link list, which is our parent, has a constructor that takes no parameters, the child deck also has a constructor that takes no parameters. So it will automatically call the parent's constructor. But if we had this guy take in like an int a, something like that, what we would then do is inside here, we would say linked list like that. Yeah, thanks. Like that, to make sure we called the parent's constructor correctly. So if our constructor for deck happened to take in a parameter, which it does not, but if it happened to take in a parameter, we can then say, this is how you call the parent's constructor, passing it no parameters. But since our deck constructor takes in, and one interesting thing here is what I just did, looking that up real quick, all object-oriented languages behave the same way in that when you have something that has inheritance, you might want to call your parent's constructor. Okay, so then the question is in this language, what's the syntax for calling my parent's constructor? So we went and looked that up real quick, and now we see how to do it. But in this case, since our constructor takes in no parameters, and our parent's constructor takes in no parameters, it will get called for us. Although I presume we could still manually do it. I could still come into deck CPP and I could still do that if I really wanted to. And just specify that here's the constructor I'm implementing, and it's done in terms of my parent's constructor, which starts off with this way. All right, but this gets done for us. And we'll try to prove that to ourselves here in a second, just so we're making sure we have good information we're operating off of. Okay, so what do we do for our parents constructor? Well, we go ahead and we build our linked list. Now, what we want to do is we want to bring some of those things. Actually, we could test this real quick right now. We're basically using deck as a synonym for linked list as it stands right now. Okay, With the, yeah, I think we're still okay. We might have to go back to linked list and make some of these things protected instead of private. So let's go into driver here. And so we'll go ahead and include deck HPP, which as of right now is effectively a synonym for linked list. We'll go ahead and create our deck of cards. Yeah, so it says this stuff is inaccessible in there. So we need to go and inside of our linked list, we're going to make these guys protected. So they're available to the children of this class. Oh, well, let's see what we got when we go back out here. Accessible for add end. Would that be inaccessible? It's a good question. Let me try something here quickly. Let's make sure that we're not, actually, I want to do it in here. Let's make sure that we're not breaking it by doing that. Why is that inaccessible from deck? I don't know the answer to that. Well, let me go and figure that out offline. So for right now, what we'll do is we'll say a deck is not actually a linked list. A deck manages a linked list, just so we can make our progress here. So we'll say inside of a deck, we're going to have a private variable of type linked list. We'll call this guy the cards. We'll have our constructor here for deck. I'm going to go back to linked list and make these guys private again. And this maybe even makes some reasonable sense, but that doesn't mean we shouldn't still figure out how the inheritance model lines up. So a deck will manage a linked list of cards. In the constructor for our deck, we will go ahead and we're going to create our linked list. So we'll say this, the cards, is equal to a new linked list. Then what we can do is I'm going to go into driver here. And I'm going to steal a whole bunch of the stuff that's up here. Let me actually just steal all of it real quick, and then I'll delete what I don't need. Don't think I'll need IO stream. Will need string. Might need standard lib. Will need JSON. Already have deck. So now that I've done that, I should be able to get rid of this. Should be able to. I'll probably still need string there. Should be able to get rid of this. I'm going to bring this guy into my deck. All we're really doing is removing a lot of our logic that we have out here. We're just bringing it inside of deck. So we're not re-implementing stuff. We're just moving things. So I brought our includes into deck. I'm now going to basically take all of the stuff that we had in here out, and we'll move that into the implementation for deck. And I happen to name my link list, I happen to name it the cards, which is the same thing we were calling it in here. And then we'll just prove it's working here. We'll say this dot the cards display. We'll just tell it to display all of our cards, proving that our constructor for deck is working. So we'll go back out here to driver. We no longer are doing really any of this stuff. All we're going to do is say deck pointer, the deck is equal to new deck, like that. Yeah, main, and if you actually, I typically call it driver. This guy is the guy that drives the program. So you should look at main and be able to basically say, step by step by step, what does this program do? Not how does it do it. If you want to connect this back to your software engineering class, I mean, it's a loose connection, but I think it's a real connection. You, in software engineering, you have a requirements document, which talks about what should our program do. And then you have the specifications document that says, how does it accomplish those things, right? So in this case, our main is kind of like our requirements document. This guy says, here's all the stuff that our program does. Boom, 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 boom. This is like the conductor of the orchestra, all right? Behind the scenes here is where the how actually occurs. Inside of this constructor for deck, we have a lot of crap. It's the same stuff we used to have out there in driver. It's not like we've written new logic. This goes back to our object-oriented telephone versus the procedural telephone. When we had this stuff out there in driver a few minutes ago, that was the procedural version of our program. Now we've sucked that into an object. It's still there. The wires are still there. We've just shoved it inside of a box. Okay. And now I can just out here in main instantiate a deck and poof, the magic occurs. So what does the constructor for deck do right now? It goes through and it does all the JSON magic, the URL magic, the parsing magic, does all that and just fills up our linked list of cards. And then at the very end, just to prove that it did it, I'm just calling the display method on the cards, just showing it's filled up with stuff. It's not, I haven't sorted it or anything. We can easily sort it. We tested that a few minutes ago. But right now this should work as is. Okay, so there's our working deck. Same output we had before. Nothing's changed. But when we go and look at driver looks a whole lot cleaner. We have a game we're making, and the starting point for our game, if we walk into a room, we're about to play a game of Hearthstone. Well, play a game of Magic is probably the better thing, because Hearthstone, you both pull out your iPads or whatever. But you start with a deck of cards. That's what I have here. I have a deck of cards. Okay. So now we want to maybe create a way to shuffle those cards. So inside of deck, and actually, why don't we go ahead and let's allow a deck to display itself, just so we don't have to hide that inside of our constructor. So we'll go ahead and add a display function inside of our public here. And this guy's going to return nothing. Then we'll go implement that guy over here. I'll go ahead and take this out. And all we'll do is call the display method of our cards linked list. That's what a deck does when it displays. All right, if you just want to see what we just did, now we can say the deck display. We taught it to display itself. All right, so now we want to teach a deck how to shuffle itself. And then we should be able to display it after it being shuffled, and it should look shuffled, right? So let's go in here and we'll go ahead and we'll do a void shuffle like this. And we'll go ahead and implement this guy. We'll put it right here. All right, so how might we go about shuffling our deck of cards the way we've, using the tools we currently have available to us? What's some suggestions on how we can shuffle? Go ahead. Okay, so we can generate maybe two different numbers, right? Two positions in our list that are legal positions, and say, I want to swap those two positions. And then just keep generating random numbers and swapping, and maybe do that 1,000 times. And we should jumble our list up pretty well. Okay, so we're going to need to be able to generate random numbers between 0 and the count of our linked list, right? And I think we have this dot the cards get count. Okay, so we need to go ahead. Well, I guess we're going to find out, aren't we? Otherwise, we'll have to go steal somebody else's swap function. We'll just keep swapping swap functions until we find one that works. This is, I'm grading your homework right now is what we're doing. Yes, live. Because obviously mine worked perfect. This is amazing. That's right. Well, I did it on purpose. Most of it was pretty good. We just ran out of time. To your benefit. You're learning, your educational benefit. He's getting merge sort tonight. If this doesn't work, he's getting merge sort. Got the whole weekend. All right. So, hold on. We probably have a snarky message. Let's see what we got. Ran out of time. You read in between the lines there. She's like, well, you get off topic pretty often. Terrible. So I was just slow, is what you're saying. Snap, snap, snap. Get with it. All right. So we need random numbers. Have we generated random numbers before? Okay, so I think it's what, like randint? Let's just look it up real quick. I think it's in random.h, and it's you got to seed it with time.h. Yeah. So let's just do C++ random int, and then we'll use mod. This should give us our couple of, here we have standard, we have time. So let's go ahead and give ourselves our time.h in here. Oh, Ninja. So we're going to be generating our random numbers inside of deck. So we'll give ourselves time.h. We use that to seed our random number generator so that we don't get the same numbers every single time we run the program. So then this is our seed value right here. So inside of shuffle, we'll go ahead and seed our random number generator. We do that with srand, and then giving it the current time in milliseconds. This might actually give us what's called an epoch, which is the number of milliseconds since 1970, but it's possible. Let's see, returns the current time. Okay, yeah, this is the current time, not the epoch. But if you ever see in programming, you ever see something called an epoch, E-P-O-C-H, that is the number of milliseconds since January 1st, 1970. They arbitrarily picked that date back when they decided, hey, you might need a number that keeps changing, that type of thing. But you might imagine the farther we get from 1970, that certainly has an end date, right? It's probably a long, so we probably have not met the number of seconds yet. We're probably actually not even close, but it's still or number of milliseconds, but it does eventually have an end date. So this just says, hey, look, if you keep running this thing, you're going to get a different milliseconds than you got 2 seconds ago. All right. And then it's what just called rand, I think, or rand int, I think is our, yeah, it's just rand. So we'll just steal this guy here real quick, and then we'll have our random number. All right, so we have our srand. So we want to go ahead and we want to generate 2 random numbers, and maybe we do this 1,000 times. So for int I is equal to 0, I is less than 1,000, I plus plus, so we're going to do something 1,000 times. All for loop is repeat something some number of times. What are we going to do? We're going to get 2 numbers. So we're going to get int pos1 is going to be equal to rand this the cards get count. So that'll give us a number between 0 and get count minus 1, which is exactly what we want. And then int pos2, get a random number between. One scary thing here, especially since you advertise you're not sure if this thing's going to work, is what if we are asked to swap the same value, swap bucket 2 with bucket 2.
I was looking like, I think that's the only thing I think swapping 2 numbers is a part of that.
Okay.
You might want to add a new statement because this statement costs you
So you wanna do this just in case we don't waste our time. So while pos1 is equivalent to pos2, get us a new pos2. And even though we're playing defense there, that kind of makes sense. Why waste our time swapping bucket 3 with bucket 3, right? Yeah. So we'll generate 2 positions. Presumably they'll be different positions, right? I don't think it's going to be very common for us to get the same random number between 0 and close to 2,000 2 times in a row. But in case we do, we'll go ahead and generate a new pos2 until we make sure we have 2 different values. All right, once we have that, then we'll go ahead and do this, the cards. Swap is private right now, right? In our linked list. So we're going to take, well, here we'll leave my swap 2 in there so you can see the shame. So we're just going to make swap a public function. That way we can call it outside of linked list. So then here inside of deck, now we should be able to call swap. What was interesting is why did it think swap 2 was legit? That's still private. That's just weird. All right, so we'll call swap, and this guy expects 2 numbers. We'll send it pos1 and pos2. And now it's good that we had figured out which one was the smaller of the 2 values, because we don't know which of pos1 and pos2 are smaller, but we know swap figures it out. All right, to swap those 2 things. So we'll do this 1,000 times. So 1,000 times we'll figure out 2 numbers that are somewhere in our linked list. They are 2 different numbers. And we'll call swap on those 2 positions, swapping the values in our deck. 1,000 times, we should have our deck relatively jumbled up. So we'll go back into driver here. So we'll go ahead and say the deck shuffle, and then we'll tell it to display itself. This is unfortunate. All right, fine. We're going to fix this real quick, but we're going to fix it the cool kid way. well, they're reasonable. Why do we have to rehook up our list way instead of just swapping payloads? So let's just go rewrite swap real quick to swap two positions, just changing the payloads in them and life goes on. All right, so we're going to decide. So let's go back in the linked list here. I'll get my, well, I'm going to call it swap. And we'll go back and we'll just dump Jason's broken code. It's complete garbage. All right, we'll go back to my swap version of this. Get rid of all that stuff. So now we know smaller and larger are two different values, right? So we'll go ahead and say card. It is called card or called Hearthstone card? Card pointer temp is equal to we already have to write set payload though. This dot get smaller. Actually, let's just put those in a couple of variables. Node pointer smaller node is equal to this get smaller node pointer larger node is equal to this get larger. And let's go into node real quick. So I know we're going to need it. We're going to have to teach it how to set the payload as well. Void set payload. Card pointer C. Then node CPP. Node pointer. This payload equals C. All right, so now a node knows how to overwrite its own payload with a new card. So what we're doing here is rather than reconnecting, performing surgery on our nodes, we're just saying, look, you got two nodes. These nodes are fine. They just represent links in a chain. So what am I going to do? I'm just going to copy one card, overwrite it with the other card, then write the card back. Swapping. Okay. No, I'm in linked list. So we'll go ahead and get the card. I'm in linked list. Get. Wait. We'll say smaller node get payload. So we'll temporarily store a copy of our smaller node's payload. Then we'll say smaller node set payload equal to larger node get payload. Then larger node set payload equal to smaller node. Actually, just equal to temp. That should do our swap. So figure out which value is smaller or larger, although we actually didn't need to do this for our swap, did we? We don't actually need to do any of that. So grab our 2 nodes, set temp equal to one of the nodes payload, overwrite that node we just preserved's payload with the other guy's payload, then overwrite the other guy's payload with the guy we preserved. And that should give us a swap. So now after we shuffle, we have a shuffled deck of cards. And if we want to prove to ourselves that our swap just worked instead of calling shuffle here, we'll just call display. What I'll do real quick is inside of display, we'll go ahead and say the cards, insertion sort on defense. So display will first sort it, proving to us that our swap is now working. So before we display inside of this function, it does our insertion sort. So we should have our defense in the right order. So Nefarian should come last. We'll go and compile this. Run this. Oh, I have in my code the word swapping a bunch of times. Give me a moment. See, hold on, I didn't save something. List insertion sort. Why is it stuck? Oh, for it to finish sorting? There's no way it took that long. Really? Oh, it did. All right, so it sorts. Man, sorting is really slow. Yeah, we don't want to sort these, but it worked. So it might be. Yeah, so here's our updated swap function, a lot cleaner. And technically, I didn't say you couldn't use, I didn't, I implied, I implied you had to do the full surgery, but I didn't say you couldn't just swap payloads like this, like I had in that previous assignment, technically. All right, so there, this is a working version of swap. All right, but we're not going to call insertion sort anymore in our display. Well, it does it for all the other stuff. This is a better swap function. You know why it's better? It's better because it works. I did, because I couldn't figure out the hard way. Well, actually more. I didn't want to spend the time to figure it out the hard way. What was I doing? Oh, I got to go into my display for my deck. And no longer do that. But now out here in driver, we will shuffle it first, then display, and shuffle works much quicker now because we're not actually swapping a zillion things. We're just swapping 1,000 things, exactly 1,000 things with no additional algorithmic stuff in there. So this should give us a shuffled deck. Seems to be reasonably shuffled. All right. So now we have our deck. We have the ability to shuffle our deck. Now we need to be able to have the ability to deal cards from our deck, right? So inside of our linked list, and if we want to, we can make this, I think we can make this cleaner. I think this would be a better way of doing it. In our implementation, we have a deck of cards. We're going to have a hand of cards, which is like a deck, right? But it's actually just a list of cards, even though we're currently using a linked list to represent our deck. It would be reasonable for us to also use a linked list to represent our hand, right? As you're playing a card game, the size of your hand does dynamically change, does it not? Okay, so we need to be able to deal cards from the deck. And when we deal cards from the deck, it always comes off the top of the deck. And then we need to be able to add cards to our hand. All right, so let's go ahead and give ourselves a hand of cards. Now, well, let's first implement dealing a card from our deck. And I think what we want to do is we actually want to physically remove the card from the deck. So we're effectively going to go ahead and do a remove front from our deck. And that one's pretty easy to implement, right? And we'll actually do it as a card. We'll return a card from the top of the deck. So we'll go into our linked list and we're going to write a function card pointer remove front. And then our implementation for linked list. I'll just write it up here. So here's our remove front. So remove front is ultimately going to have us returning the card that lives in the first node, but then also updating the head of the list, right? So, and also decrementing count. So we're going to say if this count is greater than 0, if there's something in this list. We only can do this if there's something in here, right? Then we're going to go ahead and we're going to say card pointer temp is equal to this head get payload. That's the card we're going to be returning. And actually, since I want to fully disconnect stuff, I'm going to say node pointer front is equal to this head. Then we'll say front get payload, even though those are synonyms. We didn't have to change the name of that. Then we're going to say this head is equal to front get next node. This count minus minus. Then we want to go ahead and we want to fully disconnect front. Okay, so we've updated head. Now, one thing we could probably do is ask the question if tail equaled front, tail is now null, right? So if this tail is equal to the thing that we just removed, then this tail gets the value null. Resetting the tail of the list. So that's only going to happen if we had a 1 list. Now, go ahead.
Because you have, because you have a little interest, you also protect the news from previous nodes as well.
We probably could. We probably should. I'm about to delete the memory for that, but it's probably not a bad idea regardless. So this, after we said head, this head, let's see. Well, we don't know that head is a thing or not. We'd have to ask the question if this head is a thing, because it could be null. So if head is an actual thing, and then we want to say this head set prev node to null. Like that. Some of these things are probably overkill, but you know, we can say we want to be thorough here since we're dealing with memory. Then what I'm going to do is I'm going to say front set next node to null. Front set previous node to null. So that fully disconnects it, right? And then I'm going to say delete front. And that will clean up that memory, giving it back to the operating system. All right, I would say that a pretty good chunk of this is probably overkill, what we've done in here. But we've mechanically gone through and said, you know, this is going to be the card I'm ultimately going to return. I need to remember to return that at the end, right? Return 10. So that's the card I'm ultimately going to return. I'm going to update head and tail if necessary. I'll make sure if we now have just a new head and it's not nothing, it's not nothingness, then I'll go ahead and update that guy's previous node to not point anywhere, even though the place that it would point to, I'm about to delete. But we'll just go ahead and say, look, you're going to point nowhere, so I'm going to let you know you're going to point nowhere. Update tail if we need to. Delete the memory, return the card. All right, and we're only going to do that if there's even a card to return. All right, so that's going to be our remove front. And we made that, did we make that public? We did. So now inside of deck, we're going to say card pointer deal card. So we're going to teach a deck to deal a card. Then we'll implement this guy. And this guy will return this, the cards, remove front. That's what dealing a card means. And then we'll test this. After we shuffle, we'll go ahead and deal a couple cards and tell those cards to display themselves. Now here, driver. We don't need to display the deck anymore. We're relatively confident that it's doing its thing. So now we'll say the deck, deal card, tell that card to display itself, and then we'll deal a second card and tell that card to display itself. So there's two cards dealt off the top of the deck that now display themselves. Okay. Now we're going to have a class called hand. This is when we deal a card off the deck, it goes into a player's hand, right? We haven't gotten player in here yet, but if we deal a card off the deck, it goes into a player's hand. So what's a hand going to be? A hand is going to maintain a linked list of cards. A hand should probably be able to display itself, which is just going to tell that list of cards to display itself, right? Let's just start with that. Transporting things from the deck into a hand. Okay. So we'll come over here. We're going to create a new class called hand. HPP. And this guy will be a class. Oh, that is awesome. I just pressed enter by accident. Yeah. Nailed it. Actually, you're seeing some things that this guy here, that's what happens when you delete memory for something. It'll actually go and clean it up. So like what we just did is disconnected a bunch of stuff, but this is showing this is a constructor. This is called a destructor. It'll get called automatically. But all I did here was I typed in class, but instead of typing in hand, I accidentally pressed enter. Oh, is it not going to do it now? There we go. Typed in class and pressed enter, and it populated the thing. But it actually also wrote it in such a way that it's expecting me to implement it in here instead of having two separate files. So really, it probably wanted me to call this hand.cpp and have the header and the implementation in one file. But that's not how we've been doing it. So we'll have our private section. We'll have our public section. For a hand, we're going to have a linked list of cards. So we're going to include link list. So we'll have a linked list pointer called the cards. Then we'll have our constructor for hand that takes in nothing. And then we probably need to have the ability to add a card to our hand. And then also the ability to display our hand. Oh, thank you. All right, so we'll start off with those abilities for our hand. So now we're going to go and implement hand. All right, so our constructor for hands is going to initially create our empty link list, right? So we'll say this, the cards is equal to a new link list. When we add a card to our hand, we'll say this, the cards, add end, the card. When we display, we'll say this, the cards, display. So we're implementing our hand in terms of our already created linked list. Just presumably it'll be a smaller linked list than our deck, right? Because we have a subset of our deck now inside the hand. Go back out to driver. Let's create, we'll give ourselves access to hand. And we'll create a hand pointer H1 as a new hand. And pointer H2 is equal to a new hand. And then why don't we just deal him each 5 cards? For int I is equal to 0, I is less than 5, I plus plus, H1 dot add card, the deck, deal card. And we'll do the same thing to H2. So add a card to H1, add a card to H2, add a card to H1, add a card to H2. Do that 5 times. And we'll say H1 display. We'll say H2 display. And just so we get a little visual on this, let's go into hand and CPP. And before we display here, let's do a printf. Put a couple of asterisks. Something like that. Put an extra little kick down there. We'll put an extra little space there. So fill it up. Call our display on those guys. I think we had standard IO available to us. I guess we're going to find out. We didn't like that we already had our link list defined. Let me show you something here. This will make your life easier most of the time. I don't want to include it. So we have this thing called if and define that allows you to basically not have to worry about managing this idea of has a file that I've already included a file that I'm also going to include. So if we look at the error message here, in deck, we have a redefinition of class linked list. This is in hand. Hand already knew about linked list. So let's see if I can show you that. So this is driver. Driver needs to know about deck. Driver needs to know about hand. That's true. So now we go into hand HPP. A hand knows about our linked list, which it needed to know about. That's fine. What's our implementation here? That's fine there. Linked list, new about nodes. Let's look at what the first error was. It's probably going to tell us what the problem is. So in driver, are we including linked list? Oh, deck and hand both include linked list. So what's happening here is that this guy is inside of deck HPP. We include linked list. And inside of hand HPP, we include linked list. So both of those guys are saying, hey, if this isn't already defined, go ahead and define it. So really what I should do so we get this circular argument. So what I can do is I can say if ndef, and let me make sure I get the syntax right for this guy. I think I can write it like that. It is comment H. Oh, okay, that's just the name of the header file. So I think it wants it. HPP. I don't like the way that looks. So this is like a special kind of directive. I really wish this would just say HPP, but let's see if this guy is okay with it so we get the syntax right. Oh, wrong thing. Then we need to do it in the other one. So this must not be the way to reference it. Oh, it allows us to define the name. Okay, I get it. I can name it whatever I want here. I'll do that in hand as well. Just make sure this works, and I'll explain it. Yeah, works. So this is me defining this arbitrary macro called linked list HPP. I could have called this woot LOL if I wanted to. But all it's saying is if you haven't previously defined linked list HPP, go ahead and define it and also include this header file. Over in, so let's assume we got that one first. Over in deck then, it's going to say, if you haven't already defined this, which we have, because we did it over inside of hand, we'll skip the rest of this and not include that file a second time. All right, so this gives us the ability to ask the question, if we haven't already defined something, define it, and then go ahead and include whatever header files you are. So the name of this guy is completely arbitrary. We get to make it up, probably make it something that's has a good naming convention. Go ahead. It's an if statement that asks, does this already exist? If yes, don't do any of this. If no, make it exist and then do this. So this gives us protection so that we don't have to play this game, the chicken or the egg game, where we have two different classes. We're using both of them and they both include the same header file. And we've been playing the game for a little bit without too much trouble, but now we just ran into a situation where we're dealing with decks and hands that both use linked lists. So both of those guys include linked lists. So then from C++'s perspective, we're creating linked lists twice. And it's saying, hey, you don't need to create this guy twice. Oh, we're over time already. Okay, so let's just stop there. I don't think we're at a place to really deal with homework at this point. So we'll pick up from here on Tuesday, but there's our couple of hands. Our two hands have stuff now. All right, I'll push the codes. You can go and look at it. Otherwise, I'll see everybody on Tuesday.
Just so you know, I'm pretty sure the problem that you're having with inheritance, I think you have to say public before the other thing.
Okay.
I think it has to be like, with functions with HTTP files, that we have to look at, we get a class, stack,
Got it.
colon, public.
Okay, I'll take a look.